So in this mini lecture, we're taking a look at midpoint sums. So previously, you've already looked at Riemann sums, the right and left Riemann sums. So similar to right and left sums is what this topic is related to. But the difference is how we calculate the heights, right? So for our example, let's say f of x is equal to x squared plus 1. And that's on the interval from 0 to 3. Okay, and let's say we're um, using n is equal to 3 rectangles. N is equal to 3 rectangles. So if we look at the rectangle boundaries are going to be from 0 to 1, 1 to 2, and then 2 to 3, right? With each rectangle having a width of 1. All right, so if we go ahead and take a look at that interval 0 to 1. So let's look at that interval 0 to 1. So in looking at that, then the left sums, what's the height? The height there is going to be f of 0, right? Because our x is 0. So the height is f of 0. If we look at the right sums, then the height is going to be f of 1, right? And for midpoint sums, we use the function value at the midpoint of the interval. For midpoint sums, we use the function value at the midpoint of the interval, which is 1/2. 1/2 is at the midpoint. So height is going to be f of 1/2, right? So take a look at this. We're going to have 1 times f of 1/2, right? Because we're taking all the rectangles, the length and the width, um, or the height and the width, whatever you want to call it. But each width is 1 and the height is f of 1/2. So we multiply those and then we do the next one. So the next one is, excuse me, 1 and f of 3/2. And then we take 1 plus the midpoint of the next rectangle, f of 5/2. All right, just do the computation. You should use some scrap paper, work this out, get 47/4, which is 11.75, right? So now we've found this using the midpoint sums, and we found the area. All right, so next we look at what's called the trapezoidal rule. The trapezoidal rule. So this method is much more accurate, and it just uses, like the title says, small trapezoids. So the height of the trapezoid is marked at the beginning and the end of the width interval. The beginning and the end of the width interval, which is still calculated by using delta x is equal to b minus a over n, as we discussed. Okay, so let's take a look at this. Maybe the curve looks something like this. Okay, so we have 1, 2, 3. Okay, so now we have our curve, which is the red line, and then we have rectangles, but then we have these other lines. They should represent straight lines from point to point connecting to the top of these other ones. So then they form these trapezoids. All right, so the trapezoidal rule, let's take a look at that. So it says that the approximate area beneath the continuous curve on the interval from A to B using n trapezoids, equals. So what does it equal? So here we go. It equals b minus a over 2n, and then we'll have f of a plus f, I'm sorry, 2 times f of x sub 1 plus 2 times f of x sub 2 plus 2 times f of x sub 3, we'll say plus dot 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 2 times f of x sub n minus 1 plus our last um, interval f of b. Okay, so let's try an example. Let's say we're told to go ahead and approximate. So our example says let's approximate the area. The area beneath f of x equals x squared plus 1 on the interval 0 to 3 using the trapezoidal rule with n equaling 5. I'm sorry, and I wrote rectangles, but I misspoke. They're trapezoids. Okay, so first we need to go ahead and determine the width of the trapezoids, right? The width of our trapezoids. So we're going to use delta x is equal to b minus a over n. For us, it's 3 minus 0, right, over 5 trapezoids. So then our width will be 3/5. All right, so now let's take a look at the intervals. So there are 5 intervals. So the first one starts at 0, so we go from 0 to 3/5. The next one goes from 3/5, and the interval is 3/5, so we add to that, and we get 6/5. All right, and the third one will go from 6/5, and the interval is 3/5, so we add to that and get to 9/5. And the fourth one will be from 9/5 to 12/5. And then we'll go from 12/5 and add 3/5 to that. You get 15/5, which is the end of our interval, which is 3. All right, so corresponding to the formula, I'm just going to draw arrows to what we have here. So that 0 is our A. A is 0. That's going to 3/5 is going to be x sub 1. 6/5 is going to be x sub 2. Right? X sub 3 is going to be 9/5. X sub 4 will be our 12/5. And then our B value is going to be the 3. Right? So corresponding to our formula, we're going to have, looking at the formula, make sure you're referring back, 3 minus 0 over 2 times 5. And then we have f of 0 plus 2 times f of 3/5 plus 2 times f of 6/5 plus 2 times f of 9/5, and we have plus 2 times f of 12/5 plus f of 3. right? So then you would just have to go ahead and crunch these numbers. So do that calculation. We would have 3/10 and f of 0 is 1 plus 2 times 34/25 is what we get, plus 2 times 61/25 plus 2 times 106/25 plus 2 times 169/25 plus f of 3, which is going to be 10. All right, and then continue to crunch those numbers, and we'll get 609 over 50, which is 12.18. So that's the area beneath f of x equals x squared plus 1 on the interval 0 to 3 using the trapezoidal rule with n equaling 5 trapezoids.